What is a black hole? If you care about understanding the universe you actually live in, you need to pay attention to what I'm about to tell you. Because right now, at this very moment, there is something sitting at the center of our galaxy, something 4 million times the mass of our sun, something so powerful that not even light, the fastest thing in the known universe, can escape it. And here's what should genuinely unsettle you. Scientists just proved that everything Einstein and Stephen Hawking predicted about these things is correct. Every terrifying detail confirmed. I'm talking about black holes. And tonight I'm going to take you on a journey from the very basics of what these things are all the way to the discoveries that shook the scientific world just last year. Stay with me here because by the end of this, you will never look at the night sky the same way again. Let me start with the fundamental question. What is a black hole? And I mean, really, what is it? Not the science fiction version, not the Hollywood version with some magical portal to another dimension. The real thing, the thing that actually exists out there in the cosmos right now. Here's what you need to understand. A black hole is what happens when the universe breaks its own rules. When a massive star, and we're talking something at least 20 to 25 times the mass of our sun, reaches the end of its life, it doesn't just fade away quietly. It has been burning through its nuclear fuel for millions of years, fusing hydrogen into helium, helium into carbon, all the way up to iron. And when it hits iron, the fusion stops. The energy that was holding that star up against its own gravity just vanishes. And in less than a second, the core collapses. What follows is called a supernova, one of the most violent events in all of nature. The outer layers of the star are blasted into space at tens of thousands of miles per second. But here's where it gets extraordinary. After that explosion, the core that remains is so incredibly dense, so unimaginably compressed that gravity takes over completely. And I mean completely. The matter collapses in on itself until it occupies a point of essentially zero volume and infinite density. Physicists call this a singularity. Think about what that means. All that mass crushed into a point smaller than an atom. The laws of physics as we understand them simply stop working at that point. Now, surrounding that singularity is what scientists call the event horizon. And this is the part that should really make you sit up. The event horizon is not a physical barrier. It's not a wall. You can't touch it. It's a boundary. It's the point of no return. Once anything, light, matter, information, radio signals, anything at all crosses that boundary, it is gone forever. There is no coming back. Nothing in the known universe can travel fast enough to escape. Not even light at 186,000 miles per second. Let that sink in. Subscribe to this channel right now and turn on notifications because we are just getting started. The science I'm about to walk you through is the kind of thing that changes how you understand reality itself. And I need you here for every part of it. Now, here's what most people get wrong about black holes. They think of them as cosmic vacuum cleaners, just sucking everything in. That's not how it works. A black hole's gravity only dominates when you get close to it. If you replaced our sun right now with a black hole of the same mass, the Earth would continue orbiting exactly as it does today. We wouldn't be sucked in. We'd just be very, very cold and in complete darkness. The gravitational pull at our distance would be identical. It's only when you cross that event horizon that everything changes. And here's something that will genuinely bend your mind. Time itself behaves differently near a black hole. Einstein predicted this over 100 years ago with his general theory of relativity. The stronger the gravitational field, the slower time moves. This isn't theoretical anymore. We've measured this effect with atomic clocks on airplanes and satellites. GPS satellites have to account for this time difference every single day, or your navigation would be off by miles within hours. The clocks on those satellites tick slightly faster than clocks on the ground because Earth's gravity is weaker up there. That's how real this effect is. It's built into the technology in your pocket right now. Now take that principle and amplify it by a factor of millions near a black hole. If you could somehow hover just outside a black hole's event horizon and look back at Earth, you would watch centuries pass in what felt like minutes to you. Meanwhile, someone on Earth watching you through an impossibly powerful telescope would see you appear to slow down, your image getting dimmer and redder until you seem to freeze at the edge and gradually fade away. You'd never appear to actually cross the event horizon from their perspective. That's not science fiction. That is confirmed, measured, demonstrated physics. Einstein was right. Stay with me here because I need to tell you about the different kinds of black holes. And this is where the scale becomes almost incomprehensible. The ones I just described, the ones formed from dying stars, those are called stellar black holes. They're typically between 5 and a few dozen times the mass of our sun. They're relatively small in cosmic terms. The event horizon of a stellar black hole might only be a few miles across. Picture something with the mass of 30 suns compressed into a sphere the size of a small city. But don't let that small size fool you. Within that tiny sphere, conditions are more extreme than anywhere else in the observable universe, and there are estimated to be hundreds of millions of them in our galaxy alone. Hundreds of millions just in the Milky Way. Most of them are invisible, drifting silently through space, only detectable when they happen to interact with something nearby. But then there are the monsters, supermassive black holes. These sit at the centers of most, if not all, galaxies in the universe. Our own galaxy has one called Sagittarius A star. It's 4 million times the mass of the sun. Its event horizon is roughly the size of Mercury's orbit around the sun, and that's considered modest by cosmic standards. The black hole at the center of a galaxy called M87, the first one ever directly imaged by the Event Horizon Telescope back in 2019, is 6.5 billion solar masses, billion with a B. Its event horizon is larger than our entire solar system. You could fit the orbits of all 8 planets inside it and still have room left over. Think about what that means. An object so massive that its gravitational boundary stretches farther than the orbit of Pluto. And here's the thing. Scientists still aren't entirely sure how these supermassive black holes got so big. Did they start as stellar black holes and grow over billions of years by consuming matter? Did they form from enormous gas clouds collapsing directly? Were they seeded by something else entirely in the very early universe? That mystery is one of the most active areas of research in all of astrophysics right now. And the discoveries being made are rewriting what we thought was possible. Let me connect some dots here because 2025 was a landmark year for black hole science. And I need to walk you through what happened because it confirms something profound about the nature of reality. In January of 2025, the LIGO observatory, that's the Laser Interferometer Gravitational Wave Observatory, detected something extraordinary, a signal called GW250114. 2 black holes, each about 32 to 34 times the mass of our sun, slammed into each other about 1.3 billion light years away from Earth. Now, LIGO has detected black hole mergers before. But this time, after a decade of technological upgrades, the signal was nearly 4 times clearer than anything they'd ever recorded. The signal-to-noise ratio hit 80. This was like going from watching a blurry television with static to crystal-clear high definition. And here's why that matters enormously. With that level of clarity, scientists were able to confirm 2 fundamental predictions about black holes that had been theoretical for decades. First, they confirmed what's called the Kerr solution. In the 1960s, a mathematician named Roy Kerr solved Einstein's field equations and described exactly how a spinning black hole should behave. Its gravity, its shape, the exact way space-time warps around it. For 60 years, physicists believed all black holes should match Kerr's description, but proving it definitively was incredibly difficult. GW250114 changed that. After the 2 black holes merged, scientists could hear the resulting black hole ringing like a bell, vibrating at specific frequencies. They detected 2 distinct tones in that ringdown, exactly the frequencies that Kerr's mathematics predicted, exactly as Einstein's general theory of relativity demanded. No deviations, no surprises. The math was right. If you're finding this valuable, hit that like button right now because this is about to get even more incredible. The second confirmation is even more significant. Stephen Hawking, back in 1971, proposed what's called the area theorem. It states that when 2 black holes merge, the total surface area of the event horizon of the resulting black hole can never be smaller than the combined surface areas of the 2 original black holes. The surface area must grow or stay the same. It can never decrease. This is directly connected to one of the most fundamental laws in all of physics, the second law of thermodynamics, which says entropy or disorder must always increase. The 2 black holes that merged in GW250114 had a combined surface area of roughly 240,000 square kilometers, about the size of the United Kingdom. The resulting single black hole had a surface area of about 400,000 kilometers, roughly the size of Sweden. The area grew exactly as Hawking predicted over 50 years ago. Let me say that again so it lands properly. A theorem that Stephen Hawking proposed mathematically in 1971 was confirmed with the highest precision ever achieved in human history. And here's the part that makes this genuinely moving. Hawking died in 2018. He never got to see this moment. Scientists and journalists have noted that had this evidence arrived while he was alive, it very likely would have earned him the Nobel Prize he was never awarded. Now, I need to tell you what else scientists discovered in 2025. Because the James Webb Space Telescope has been finding things that nobody expected and nobody can fully explain. Researchers using Webb confirmed the most distant black hole ever found. It exists inside a tiny galaxy called Sears LRD-Z9, and it's present just 500 million years after the Big Bang. The universe is 13.8 billion years old. This black hole existed when the cosmos was just 3% of its current age, and it's not small. It's estimated at up to 300 million times the mass of our sun. Its mass makes up roughly half the total mass of all the stars in its galaxy combined. That ratio is staggering. In our galaxy, the central black hole represents a tiny fraction of the total stellar mass. This thing dominated its galaxy. Here's where it gets genuinely terrifying from a scientific standpoint. Our current models of black hole growth cannot explain how something that massive could have formed that quickly. There simply wasn't enough time according to everything we thought we knew about how the universe works. These objects are forcing scientists to fundamentally rethink the mechanisms of how black holes form and grow in the early universe. Some researchers are now proposing that certain black holes may have formed through something called direct collapse, where enormous clouds of primordial gas in the early universe collapsed directly into massive black holes without ever forming stars first. NASA's Webb telescope even found potential evidence for this in a remarkable object nicknamed the Infinity Galaxy, two colliding galaxies with a black hole forming in the gas between them. That would be an entirely new pathway for black hole creation. Drop a comment right now. Tell me where you're watching from. I want to know how far this is reaching because this kind of science matters to everyone on this planet. And there's more. In mid-2025, astronomers discovered the densest cluster of supermassive black holes ever found in the universe. 11 active supermassive black holes called quasars packed into a region just 40 million light-years across dating back 10.8 billion years. The odds of that happening by random chance are essentially zero, a 17 sigma outlier. For reference, physicists consider 5 sigma to be the gold standard for confirming a discovery. This is 17. It suggests there are processes at work in the universe that we don't yet fully understand. And just when scientists thought they had a handle on how these objects behave, a rogue black hole was discovered tearing apart a star, not at the center of a galaxy where these things are supposed to live, but far away from any galactic core. The event, named AT2024-TVD, produced the fastest changing radio emission ever recorded from a black hole consuming a star. It shattered assumptions about where supermassive black holes can exist and remain active. On top of all of that, researchers at the National Observatory of Athens published findings suggesting that something fundamental about black holes may actually be changing over cosmic time. The relationship between ultraviolet and X-ray light emitted by quasars appears to have shifted over billions of years, suggesting the material around black holes doesn't play by the same rules it once did. Stay with me here because I want to connect all of this for you. What we're witnessing right now is nothing less than a revolution in our understanding of the universe. In just the last few years, we've gone from having theoretical descriptions of black holes to directly imaging them, hearing them collide through gravitational waves, confirming the mathematical theorems that describe their behavior, and finding them in places and at times in cosmic history where they shouldn't exist according to our models. And here's what makes this relevant to every single person watching this right now. Black holes are not just exotic curiosities. They are fundamental to the structure of the universe. Every large galaxy appears to have one at its center. The energy released by supermassive black holes influences how galaxies form, how stars are born, how heavy elements are distributed through space, and ultimately how the conditions for life itself came to exist. We are in a very real sense shaped by these objects. Let me leave you with three things. First, black holes are not destroyers. They are architects. They helped build the very galaxies we live in. The matter and energy they process, the gravitational influence they exert, all of it plays a role in the cosmic structures that make our existence possible. Second, the confirmations of Einstein and Hawking's predictions represent one of the most significant achievements in the history of physics. We are living through a golden age of discovery, and the tools we now have, LIGO, the James Webb Space Telescope, the Event Horizon Telescope, are giving us answers to questions humanity has asked for thousands of years. What holds the universe together? What happens when gravity wins? For the first time in human history, we have the instruments to answer those questions. Third, we are just beginning. The discoveries of impossibly early supermassive black holes, rogue black holes outside galaxies, and evolving black hole environments all tell us the same thing. Our models are incomplete. There is more to learn. There are mechanisms at work in this universe that we have not yet imagined. And that, to me, is the most exciting thing of all. We live in a universe where objects can warp time itself, where the collision of two invisible objects 1.3 billion light years away can make the Earth vibrate by less than the width of a proton, where a telescope orbiting 1,000,000 miles from Earth can look back 13.3 billion years and find monsters that shouldn't exist. This is the universe you live in, and it is far more extraordinary than most people will ever realize. Make sure you're subscribed with notifications turned on, because I'm going to keep bringing you the science that matters, the discoveries that change how we understand everything. Share this with someone who needs to see it. I'll see you in the next one.